Fantastic. So today is the 2nd of July, 2025. This is the working group for measuring the impacts of funding of open source software. And just to repeat for the benefit of folks watching this afterwards, today we have a speaker, Dr. Mirko Bohm, Senior Director of Community Development at Linux Foundation Europe, and he's going to be presenting key findings from his blockbuster report, The Impact of Open Source Software and Hardware on Technological Independence, Competitiveness, and Innovation in the EU Economy. So perhaps without further ado, Mirko, I can pass over the mic to you. And I know you have some slides, so please feel free to share your screen and take it away.
Yes, can you see my screen? And you can also hear me well? Yeah. Okay. So thank you. Thanks for the welcome, Kaylin. Thank you for the opportunity to present. So this is like a tailor-made custom presentation about this subject, not the standard, what is the impact of open source software and hardware on all these things in the EU presentation, because you can actually see that on YouTube already. And the report has been out for a couple of years. What I did instead is I looked a little bit more deeply into what the methods are that we applied to measure the impact of open source software and of hardware, and how this was all calculated at the macro and micro level, because I thought that this would be interesting for this group. So I will present some findings, but there will be a somewhat longer section on methodology. And I did plan with 15 minutes, so I'm not going to go super fast, but I will probably not need an hour. So very happy if you have any questions, feel free to type them in the chat or interrupt me. Happy and okay with that. All right, so this is the report we're talking about. You can get it at the European Union website. And it was published in 2021, and most of the work that I will present today was made between 2019 and 2021, and mostly based on data that ends in 2018. And the reason is that we looked at years that were complete at the time. So that's why you find a lot of numbers that relate to 2018, and many of the time series that you find in the report span from 2008 to 2018. Maybe upfront, I don't believe that many of the dynamics visible in the charts and data have changed significantly. Things grow, things evolve, but there was no major disruption. So I think most of the things you will hear today are still valid. All right, so let's just to get your appetites wet and your interest levels raised, give you some of the high-level insights up front. You've probably seen the number of 65 to 95 billion annual contribution, billion annual contribution to the European GDP, which represents between 0.5% of total economic output. This is a headline figure, right? This is something that we've communicated very widely, but it's a significant impact if you think about it, considering that very few people do open source development for open source development's sake. They do that to have fun with it, or to learn about it, or to build their companies. So if we can grow GDP like that, by people working in a certain way that is also more efficient and more fun for them, that's a pretty good outcome. European companies made more than 30 million commits in 2018. And that represents around 1 billion euros investment in open source. One thing that you will see is that the EU as a body actually plays, I don't know, boxes pretty much at its weight when it comes to contributing to open source software development, which is a bit in contrast to the role it plays globally, to the impact it has, that the European region has on setting the direction for key technologies. And of course, in terms of the commercialization of the outcomes, that often doesn't happen in Europe either. So we'll see about that. The one very interesting number that we try to calculate is the cost-benefit ratio. So basically, €1 that is invested into open source development, what is the GDP impact of that? And all our calculations generally have been on the careful side. So if there was a range, what you find in the report mostly is the lower bound. So we would say this is a number where we are relatively sure that it can actually be reached, that this is realistic. Could be more, but we don't believe it's significantly less than that. So then 1.4 is actually um, quite a great benefit ratio if you think about it. And that means that if you would increase open source adoption by 10%, you would get another 0.5% of GDP in the EU, or it would translate to 600 additional ICT startups. There's a bit of math behind this, econometrics, that says what is the correlation between R&D spending and startup fund formation and things like that. And based on that, this is calculated. The contributor base in Europe is significant. At least 260,000 people have contributed on GitHub, primarily in 2018. 8% of the people who are working in Europe in the computer programming sector. So that's actually not a huge number. It could be much more, right? So I think every computer programmer should contribute to open source. So that number could be 100%. But we have to also keep in mind that people have a day job, they work on, something they get paid for, and they contribute as part of their day job to an open source project here and there, for example. And then in that regard, if you look at it like that, then 8% is actually quite good. And one interesting insight is the market structure in the European region, which is a bit different from what we see in North America. The companies most likely to contribute, or that whose employees are most likely to contribute, are small and medium-sized businesses in Europe. In the US, most commits are made by large companies. I think this represents the general market structure. So the way the ICT industry is set up in North America versus Europe, in a way, reflects on this finding. But I think it's still significant because it means, for example, that questions like how accessible are innovation mechanisms, be it open source development or standards development or other things, or policy representation for small and medium-sized organizations, that will have a bigger impact in Europe compared to other regions. Yeah, so those were just some headline findings I wanted to give you up front to get you interested. And here's some background about the study itself. It was commissioned by DG Connect of the European Commission and consisted of course, a literature review and then case study work, especially in relation to open hardware, because even today still the open hardware ecosystem is pretty much at an early stage. It doesn't have the size, the scale of collaboration, or the output compared to the software ecosystem, basically. And as such, it is difficult to do quantitative analysis. Basically, there's no GitHub where you can have thousands of people collaborating, or hundreds of thousands. There are repositories, but it's all a pretty much smaller scale. And you don't have this strong interconnection between projects that we call the upstream-downstream network, where all the open source projects have a relationship to each other. Hardware projects are not like that. So because of that, the research into open hardware was more qualitative, interview-based, case study-based, and there was a survey as well. And for the econometric analysis, which is more focused on software, this was hard math, basically statistics, based on data that I will present in a bit. There were a couple of challenges in this study. The first one being that there is no fully established methodology to measure the impact of open source software, especially not 7 years ago. I think we contributed a little bit to that, but we didn't solve this problem completely. We're still seeing efforts today to develop that, and the CHAOSS group is, one effort, one part of that. So basically, as we were working on this, we had to come up with our own method, essentially, or develop our own method. One reason for this is that the standard econometric frameworks do not capture non-market activities in general. So um, you may be surprised that but most of what we know about GDP is either based on taxation or on surveys for companies. So companies report their data to financial authorities or to market surveillance. Um, but it's all based on commercial activity. And many of the contributions to open source software are not like that because they are done mostly by companies for the most part, like the majority of contributions come from people in their day job, but there's no direct monetary exchange associated with making a contribution. And as such, they don't show up in, for example, value-added tax statements and things like that. So you have this whole like shadow economy next to what we can measure, um, which we know has a noticeable impact. Um, but yeah, generally we just don't measure it very well. And that's why the study is, I think, is important. Another aspect that makes this complex is that many of the impacts that we associate with um, general open source development and open source adoption are spillovers, indirect effects. So for example, we build better foundational software that is then used in many products. Or one thing that is interesting is that open source has actually enabled the reuse of software. Before open source was quite prevalent, software was mostly fire and forget. It was developed for a product, the product was released, and the next generation of this product would have started from scratch or almost from scratch. Um, and the change that open source imposed on the ecosystem is that we are now seeing much more incremental development. Same components are developed over a long period of time and then assembled. And this is a spillover. This is a change in how we learn about software engineering, how we collaborate on it, how we reuse components. And that's even harder to measure, basically. And as I already said, the open hardware ecosystem is still in an early stage, and there's very little substantiated data, empirical data on its economic impact. So this was mostly to yeah, give you an introduction to the study, and then now I would like to go a little bit into the methodology against the background that this is the CHAOSS working group for measuring open source. I added a little bit more detail there. Um, so the first thing is the study is a supply side study. So we looked at what do contributors do, what do developers do, what do companies contribute to the open source ecosystem, how do they benefit from that? We didn't look much into the consumption of open source, and I will show you later who did more work on that. Um, the supply side was modeled based on a theoretical framework based on case studies and taxonomies. For example, there's a whole chapter in the report that says what are the business models that we see. Um, how do we define openness? Because especially when, for open source software, it's very well defined what the open source definition is. So the full freedoms, what is open source is a question that we can answer pretty well. For hardware, it's more of a spectrum because you can have um, hardware specifications that are freely licensed. Sometimes you have the tools to develop these specifications also free, and sometimes the tools are proprietary, then the specifications are free, and then you get this like spectrum of how open is this? It's not black and white as it is in open source software. Um, and for that, we built these taxonomies. And there's a whole chapter that basically says the openness debate, like what is open in the context of open source. And I think that is actually quite interesting because these discussions were they're much more prevalent, let's say 10 or 12 years ago in the community. We were arguing more about what does open mean. But I think at the level of giving recommendations to policymakers, this is still quite relevant. And we do realize that not everything is as easy as it is with open source software. Yeah, and our one limitation of the study is that it focuses on commercial activities or commercially motivated activities. This is, I guess, similar to the how do we measure GDP? It says like, what can we measure? What can we see? Volunteer activity is very difficult to track. But also we know from multiple research findings that volunteer contributions in the global scale of global scheme of open source are a minority, unfortunately. So we would like to see more, but we know that the corporate people in their day job basically dwarf the contributions from individual volunteers. So based on that, two combining approaches, basically. One is the reconstruction of developer time based on GitHub data. There was also a discussion about is GitHub enough? But if you look at it from a econometric perspective, saying, can I get 97% of the data? GitHub is what you want to start with, because that's where 90% of the activities is or more. Maybe not on hardware, but for software. Interestingly, we applied the COCOMO model, which is quite old, and some people consider it outdated, but whenever people try to replace it with something more modern, eventually people fall back to the COCOMO model. It's a bit surprising. It's crude, but it's well understood. So basically, using that, we modeled about 10,000 active open source projects and adjusted the outcomes for the European situation, European developer costs, productivity factors, etc. There's a very interesting approach in here, and that is every contribution is basically calculated as one line of code. COCOMO measures lines of code, and normally you would say, well, but if one contribution is 100 lines of code and one is one, that's a distortion. So yes, it's a distortion. And that's one reason why we say the results that we publish are a lower bound of the actual impact. So we say that's like the minimum contribution you have to make a commit is to change one line. So we know that at least each commit is at least one line. Actually, in average, most commits are closer to one line than you would think, because many commits are either one-liner changes or simple fixes, etc. So this is not as wrong as it might appear initially. So it's a very crude but quite effective way to feed the COCOMO model to estimate the developer time. But it's something that we have to be aware of when you look at the results, because that's one of the reasons why we say the results are a lower bound of the actual activity that we can measure. And then, yeah, we did a hybrid approach of combining commit analysis with survey data. So in the survey that we shared, we asked people, how much time do you spend on open source development as part of your day job? How much do you do in your private time? Is sometimes work on your more privately interested projects also supported by your employer, things like that. So, and this all gave us data points to create a model. On the macro level, we have essentially two sources of data. One is related to open source, and one is general economic data. And the approach here is essentially to say, let's measure what the open source community does, and then let's measure what the European economy does, and basically how the open source community fits into that. What share of that of the overall economy is it? So the open source related data sources are, as I said, GitHub. At the time, there was the GH-torrent project, good friends of us who basically made GitHub metadata available. And this was very welcome because we used it in the analysis. And we did review GitLab and Software Heritage, but at the time, including their data would not have changed the outcome, basically, because so much, like an overwhelming amount of activity is focused on GitHub. And this was combined with general economic data, so Eurostat, the OECD database, Crunchbase, a company database, and Amadeus. So these are European or data sources available to academics, partially, that focus on the corporate structure of the economy. And one thing, as you will see in a bit, I think, is that we try to associate activities with companies and then associate companies with member states, like where are they based? And for that, these databases were used. And with that, we could build a kind of a mental model of saying, this is what the European economy looks like, this is what the economy in the member states looks like, and this is how open source activity is associated or related to the European economy and the member states. And this was then used to create time series for activity from 2008 to 2018. And it's all supply side focused because at the time, data about the diffusion, meaning how is open source adopted on the demand side, was not generally available. There was no survey, no insight, and I think still there isn't, except for some databases. But the situation hasn't changed very much. So that's the reason why our study is mostly supply side focused. Now this is macro level, meaning looking from the top at the whole European and member state economy. Then you have a micro level perspective where we disaggregated this data at the organizational level. This is where the GDP, the economic databases came in, the company databases, etc. There's a certain margin of error here. Like you're basically saying, based on the email address of a developer or used in a specific commit, I can associate that commit with a company. Now we know that people, for example, work in different organizations or they associate themselves with different organizations over time. I think this was for the most part corrected for. Um, but yeah, that's basically one of the challenges here, of course. So if you look at how the data broke down from the very top, we had 32 million active users in 2018, of which we could link 600,000 to organizations, and of which we picked 10,000 organizations that had the highest number of contributors. And we matched 2,000 of these companies, of these organizations, with the databases that we had about the EU. And this gave us a picture of like what is the activity in different member states. And of these 2,000, we had very detailed data actually, about 1,000 of them based on mostly the Amadeus database, if I understand correctly, or remember correctly. This allowed us to group this by sector, employee count, turnover, etc. So I think one of the achievements here that I'm a bit proud of is that we were able to take this whole, I don't know, lake of data and make it so structured that we were able to say, how does this represent sectors of the European economy? And that's something that wasn't at this level was not done before, so I'm quite proud of that. And one thing that this data crunching, number crunching exercise does not provide is insights into the cost benefit ratios, like the idea of if I invest €1, how much do I get back? So this was then based mostly on the stakeholder surveys. This is how this fits together, basically. So we have a cost assessment based on this like huge amount of GitHub data. And we looked at this at the country level and at the company level. So basically, at the country level, looking at what are the investments per country, what's the cost-benefit ratio there, what does it contribute to GDP in that country? So quite direct, interesting outcomes. And at the organizational level, what do organizations invest into contributions to open source? How did they benefit from that? What's the motivational impact, etc. Yeah, so this is the methodology. As I said, I wanted to give you a bit more detail here, but in the hope that this helps, for example, develop further models for measuring open source activity. So I hope this is useful. So some highlights of insights. The report is very long. It's over 300 pages. It was a team effort. I'm one of the authors. I'm not the only one. And we worked on this for more than 2 years. So it's this is a report that if you want to read it back to back, you will have to spend some time. But it's a very good executive summary. So one thing that I wanted to highlight is numbers of companies contributing per member state. Basically, the distribution of open source activity over the European economy. And you see I think it correlates primarily to the size of the economy, which is not surprising. So the number of people correlates to the number of contributors in that country. But it also means that pretty much all over Europe, you have open source activities. Small countries are visible, even if they're sometimes very small. They can have a significant share and show up on the pie. If you aggregate that, I didn't put this in here, sorry. There's a stack chart. The contributions from the EU are actually quite on par with other regions. So we don't have to hide. We're actually quite good in contributing to open source. So the interesting thing here is that essentially open source contributors are all over Europe. One thing, maybe side note, we were talking about diversity and inclusion recently, and that in a related discussion, and that people are at a disadvantage if they don't have English as their native language. This is true, but in Europe, it's more like everybody is using English as a second language for the most part. So it's more like the barrier is the same no matter where you're from in Europe, except from the UK. But yeah, so the interesting thing is that compared to other regions, there is not a dominant language that is the native language of the region. So Europe has many languages, and therefore pretty much everybody contributes with English as a second language, basically. And I think that's an interesting insight because it does show that European communities are often more aware of the need to be inclusive and diverse. All right, so companies contributing to GitHub per member state per employee class. Now here it's interesting. This substantiates the claim that small, medium-sized companies are more active in Europe. If you look at from the right to blue, orange, gray, and you get to the yellow one, that's 100 to 250 employees. So that's medium-sized companies. That's still not a very large organization. And that's already 60 to maybe 70% of the pie. So the most contributions in Europe come from very small organizations. And also keep in mind that we have this like 35% of organizations that didn't give us any information about that. So this is kind of a visualization of the claim that in Europe, the open source ecosystem is shaped more by small, medium-sized companies and maybe also by individual developers, solo entrepreneurs and others. And that's something to be aware of and to reflect in policy measures, for example. When it comes to cost-benefit ratio, there's this interesting matrix of like, what's your cost? Is it very high or very low? And how much benefit do you derive from your engagement in open source? And you can clearly see that in this heat map, the low cost, high or very high benefit, this is where the green bars are, this is what most people say. So the impression that most participants have is that there's a low cost of participation, and they draw significant benefit from that. And that's a good message. Basically, it means that that the idea of the virtuous cycle is working, that people perceive this as useful and low effort, and therefore would like to contribute more. And yeah, so the cost-benefit ratio that you can calculate from the survey data is about 1 to 10. And then if you include also hardware cost, then that's the number we communicated, 1 to 4. So €1 investment gives you €4 in benefit. All right. So then some noteworthy findings. We had about 260,000 EU-based software contributors in 2018, which means that about 230,000 full-time equivalents of basically people working in IT in Europe are related to open source in terms of their employment. This doesn't say that 230,000 jobs are created because of open source, but it's something that where it's like, for example, mentioned as you should know this, or you should be able to contribute to that. And I think that's a pretty significant number. I already mentioned that there's a high share of small companies that are actively participating. The two key drivers, the top two that people mention for their own adoption of open source is identifying technical solutions and avoiding vendor lock-in. So it's also pretty intuitive, I think. And from the qualitative reviews, we found that many important open source software and hardware projects are actually founded in Europe or based in Europe with their headquarters. And interestingly, they're often not even recognized as European innovations. So you see this, we interviewed the Octo project and others, who are all organizations communities that originated in Europe, and are kind of not recognized for that. So Europe does contribute, our region does contribute a lot to open source, and sometimes you have to tell people, I guess. And one outcome that I wanted to highlight, because this is important to me, is that the combination of open source licensing and patents is considered pretty toxic, toxic for collaboration, basically. And as a result, people avoid it, and it's not very widespread. And that's great. Okay, of course, 2018 is a long time ago in terms of science, right? So I wanted to highlight that there was a follow-up research effort at Harvard that complemented what we did with a demand-side approach. And the numbers are different, but if you look at the key findings, they mostly confirm what we found in our report on the supply side. For example, the usage data at the firm level, and also the methodology of evaluating everything. So demand side was validated at 8.8 trillion, which is of course much bigger than the impact that we uh, measured for the European economy. But yeah, let's keep in mind that there's a difference between demand and supply here. Supply means what do we invest in terms of actual like development activities and building products. And demand means everybody can use this, and therefore that's the benefit people draw from the available open source software. So of course this number is much bigger, but the outcomes complement each other and support each other. Both studies use the COCOMO model again, so even in 2024, we still see COCOMO developed, applied, sorry. And in terms of, that I remember that I said that it was difficult to say what is the adoption data of open source, and Harvard here used Synopsys and like the Linux Foundation census data to basically calculate that. So there is a bit of insight in how do people adopt open source. This is something that our study couldn't cover. Yeah, and interestingly, the policy recommendations also support each other. So we see that what we have published 7 years ago is now leading to further research and used there as well. Yeah, so some implications and limitations from our study. One thing, so maybe again, I'm not giving you the full presentation. I'm not reciting all the policy recommendations. I recommend you look into this if it's interesting to you. So I highlighted a few things that were important to me. This part is especially important to me because it's one part I worked on in the study, and that is what are the like negative effects of open source development? Is there something like a dark side to open source? And we picked up many of the arguments that were made by various groups. And one of them is that cloud businesses kind of intercept and monetize open source. They create proprietary derivatives and host them in the cloud and don't contribute back to the community. This is a bit biased, of course, but the finding that we have in the study is that that's actually their role, and it's to be expected. Because the cloud providers act as vertical integrators, and their role is to take the existing software and to make it available for end users. And as such, their interests are probably to have the software stable and well maintained, but not for it to change a lot. And they also don't necessarily have an interest in changing and adding functionality on their own unless it's necessary for them. So we identify different roles here, the roles of the original developers, maintainers, and of vertical integrators. And these roles come with different interests. And these different interests translate to the motivation or not motivation to contribute and change the software. So that was the first argument. I think it's pretty much debunked with that. If you look into it, I understand that reasonable people can disagree on this. But I think it's an interesting argument to make. The next one that we picked up is this big tech siphoning off the open source ecosystem. I think the main reaction here is that if you look at the largest open source contributors, these are the same companies. So yes, you can say that big tech companies benefit massively from the existing open source technologies. But if you look at contribution data, you can't say that they're not giving back. They're in all the major projects, also the major contributors. So kind of these are all arguments that are like taking headline arguments that people bring and try to like balance them a little bit or give a bit of context to them. Another one that we looked into is the development of ethical source licenses. This was something that was quite hot in the time when the report was written. I think this has died down a little bit. And one thing here was that there are arguments made that ethical considerations should not be added to open source licenses because open source licenses say that everybody can use the software for any purpose. Anybody can use the software for every purpose. You know what I mean. And I think the key statement here is that this doesn't mean that we think human rights and other things don't have a place in open source. Actually, I believe that the open source community has a strong focus on supporting that. It is just that the definition, the open source definition that defines what an open source license is, may not be the right place to defend human rights. So we basically recommended that this should be addressed, but not in the open source definition, basically. And there's a last argument I wanted to highlight, and that is potential downsides of sharing, in this case, intellectual property rights, but this means source code or open source software projects. Um, from a geopolitical perspective. So basically, if we do that, don't we give away all our innovations for free so that other people can contribute, can compete with us, other regions? And we said here that open source licensing is essentially also an instrument to policymakers. This also reflected then into our policy recommendations, where we said you can use open source licensing to say which technologies should we not compete over. If you make sure that technology is available under open source licenses, it is available to the whole world. It's the tide that raises all boats. So you have an instrument at hand that says, I can define where can I compete, where should my industry compete, and where shouldn't it. And that's an interesting, a difficult instrument to wield, but it can be quite effective. One thing that we did highlight is that there are some implications involved, like competition. Competition, essentially, international competition is based on price. And based on price means it's also based on living standards of the people working in the factories. And we have a certain perspective here in Europe, how this should be, what the minimum standards should be. And we compete with regions that don't respect similar standards. And that's difficult. But we said this is not something that the open source ecosystem can solve. This is something that policymakers need to pick up. And yeah, so the highlighted sentence at the bottom is interesting. So open source collaboration is very much an instance of creative destruction, right? It's this we have this constant renewal, new ideas come up all the time, and of course that means that old projects are now outdated and not used anymore. And these different aspects, these different arguments that are brought represent the more destructive approach or aspect of creative destruction. There's just constantly something new. There's always somebody who benefits and somebody who loses. And these arguments are usually brought by the people whose business models aren't working so well. Yeah, so maybe one limitation to our study is that, of course, this focuses on the economic impact. Now, that's not the only thing in the world that matters, right? So besides the fact that we only use GitHub as a data source, there are other important dimensions: sustainability, equity and inclusion, democratic governance, open science, things like that that are listed here. And open source can support all of these, but our study didn't measure them. So in short, these are the policy recommendations that we made. A very high level, only the summary basically. Key takeaway here is that open source generates significant positive economic externalities in the EU and elsewhere. Basically, it's a public good and it contributes positively to the common good. And therefore, it's something that our policymakers should be interested in. And then we give recommendations like the public sector should adopt open source more forcefully. We should look into adopting open collaboration methods in science. And we should make our industry competitive by making open source very central to it, basically. And I think I did take a lot of time. I hope it was interesting. That's it, what I wanted to present. And I think we have time for a few questions.
Brilliant. Thank you so much, Mirko.
I have no idea why I thought that I can do this in 15 minutes. So I'm glad that you didn't show up.
I'm glad you said that. I was considering making that comment, but no, that was really, really great. Strictly speaking, we have 3 minutes left for Q&A. I certainly have one question.
We go until 10 till, so we have 7 minutes, 8 minutes.
Okay, great. So I have one question, but I'd be happy to let others go first. So if you have a question, please raise your hand, and then we can ask more questions. Has anyone raised their hand? I don't see any yet. Okay, then I'll ask my question in the meantime. Yeah, Mirko, you're definitely too humble. You made a significant contribution, and we, as members of this community, of this working group, are building on the standing on the shoulders of giants, and you and your co-authors' shoulders are some of those shoulders that we're building on. Now, so a question is centered around your kind of advice for future research on this. So taking the adage that all models are wrong, but some are useful, imagine someone wanted to do a similar study using a similar approach to modeling the supply side value of open source in their national economy or regional economy in 2025. What would you recommend that they do differently to what you did based on your learnings of implementing this methodology?
So first, I wouldn't say that our methodology would be completely wrong today. It was a trade-off at the time, and it would still be a trade-off. For example, GitHub still dominates open source development. So if we want to measure the activity mostly on the software development side, I think you would still be pretty good with measuring it. I would primarily recommend that this kind of data collection and modeling should be done more permanently. We did a snapshot. I believe that researchers and the European Union should have an interest in doing this on a regular basis, like a panel approach over the years, to see how does our open source contribution or activity evolve over time. And in that, if you do that, then you can also refine the methods. I'm pretty sure you can do more refined math on this year by year. But I would probably say also I think there's a lot of value in being able to compare your results with the previous studies, to use a similar model, a similar approach, adapt it to your needs, and then I think you should be well on your way, basically.
Okay, brilliant. Thank you. Does anyone else have any questions for Mirko?
I have a question. Maybe two. So first question is about, we're talking about the value of like code here, but we also know open source, there is a lot more than the code to make a project successful, such as like marketing work, design work, things like that. Do we consider them as like cost of production, or do we actually consider that as a part of GDP value that we didn't capture? And the second question actually is, you mentioned that like probably government should use open source as an instrument for their policy making to decide what business we should compete against and which part we shouldn't. Then do you have any estimate, like a forecast about like in the future, which area might be have more restriction in like open sourcing? Thank you, Mirko.
Okay, so first question. I was thinking about the second one. I forgot the first. So I'm going for the second one first. A good example is cloud technologies. By adopting cloud native technology everywhere, we've basically said we're not going to compete anymore about how a data center is run. That is what I meant earlier with the you can define which technology areas there should be competition about and which are basically the state of the art is open source. What this means is that the competition is moving to a high level in the stack. That's actually something we elaborate in the study. It's like we're not competing anymore over cloud orchestration. That's pretty much done. Now we're competing over who can provide that most efficiently. It's a competition over price now. And this is an instrument that politicians can use. Where is this applicable in the future? I think data centers are still one way, but another one is definitely telco. So we have this regional telco competition, I think, still in place. And one way where we see the open source sets the baseline is O-RAN, the new technology that is emerging next to 6G, I think, 5G, sorry, for more self-hosted communication networks. And that's open source for the most part. As a result, we see increased competition about deploying it and less about owning the technology itself. So that was that's an example where I think in the future we can see more like creating markets based on open source technologies and moving the competition up to the services that are provided to consumers. The first question was about?
Was about like, to make an open source project successful, there is
Yes.
marketing, there's design, other kind of activity
Mhm.
involved. Do we consider them as cost for the project, or do we consider them as a value, GDP value that we didn't capture?
I would probably say, unfortunately, this is value that we didn't capture. There's a lot of value in our economies that we don't measure in GDP, like people helping each other, right? So, and this is a similar thing. Because of course our econometric approach was mostly based on technical activity, on contributions, and that means that we have this whole cloud of work around this that is not visible in the repositories, and you don't measure it the way we did it. Is it a cost? Yeah, of course it's a cost because it has to be done, but I think this is probably also the communities do receive funding, for example, through membership fees and other things. And this is how, if this is paid by the community, this is how this is funded. And so maybe this is something that if we look into funding structures of communities, especially of commercially driven organizations that have members, then we would see this more represented because the event organization and the marketing, etc., there is more formalized. There are actual teams that do that. But this relates, your question relates to the debate in the volunteer community where people sometimes say that technical contributions are valid and visible, valued and visible, and other contributions are receiving less attention. Yeah.
Excellent, excellent. So we've reached the end of today's session. Thank you so much, Mirko. This was really great. Just to wrap up, normally at the end we discuss upcoming events, but I noticed in the agenda that we haven't got any written down. If there are any events that are coming up that are relevant to the work we do as a working group, please feel free to share them now or write them down in the agenda for the next session in 2 weeks' time so that we can discuss that. If there's nothing else anyone else wants to say, I just want to say thank you again to everyone for coming and look forward to seeing you next time.
Thanks, everybody.
Thank you. Thank you, everybody.
Thank you.
Bye-bye.
Thank you, Marco.